Okay, pre-calc fans, today we're going to be looking at two things. Domain restrictions, number 2, and then we're going to look at some operations again, but in a different fashion. Okay? So let's begin with some more challenging domain restriction problems. So the other day when we did our domain restrictions, I kept it pretty basic. Okay, we had no quadratics underneath the radical, and we never had a situation looking like this. When we had radicals, they were either by themselves or else they were just at the bottom and nothing fancy on top. Okay? So, here we actually have a double whammy. We have stuff going on the bottom. We have stuff going on the bottom, and we have stuff going on top. So on the bottom, what do we say? That's right, x cannot be, so on the bottom right here, that x cannot be negative 8. All right, then what do we have to say about the top? We also have to look at the top for this one. That's right, x plus 7 has to be greater than 0. So x has to be greater than negative 7. Okay, we're in pre-calc. We're going to write this out using our interval notation. So the domain is negative 7 to infinity. Ooh, greater than or equal to. I can include it. I can include 0. Remember, I can take the square root of 0. Nothing wrong with taking the square root of 0. Now, this is the domain. Notice I left out x does not equal negative 8. Why did I do that? Well, the only one here to answer me is the dog, so negative 8 is not in this domain value. Negative 8 is less than negative 7, so we don't have to worry about this. Okay, so we don't need to worry about negative 8. If we had a number that was in between negative 7 and infinity that had an issue with the bottom, then we have to say x does not equal whatever that number would have been. Okay, we'll see it again. Okay, we'll see it again. All right, let's look at this one. So now we have a quadratic underneath the radical. So it's x squared minus 36 is greater than or equal to 0. So now we're actually looking at a quadratic inequality. Okay? So when we solve these, remember we have to do our factoring. So we have our x minus 6x plus 6. So we have negative 6 and 6, and we're going to look at this on a number line. Because we need to know, and these are closed circles, we need to know where to shade. We need to know if we are in between here or if we are on the outside edges. Okay, so all I'm going to do is pick a test point. I like 0. Okay, I plug in 0 here. Negative 36 is not bigger than 0, so we are shading to the outside. So these are your solutions. So your domain then is negative infinity to negative 6, union, or else you can write out the word or, 6 to infinity. And these are brackets. Okay, I ended up picking a test point. I like 0. I plug 0 in. 0 minus 36 is negative. Is not bigger than 0. Okay, so it's not true in the middle, so it's true on the tails. Okay. All right, here's another one. Here's another quadratic underneath the radical, and we have this x minus 4 in the denominator. So I'll take care of the denominator right away. That's right, x cannot be positive 4. All right, let's set this greater than or equal to 0, and then we'll factor it. And I'll factor it. So we have our number line of a 0 and a positive 7. So now the question is, where do we shade? Well, I can't pick 0 because that is one of our critical points. Yes, these are closed circles. That'll help me to remember to not use parentheses. I'm going to pick 1. Well, 7 minus 1 is 6. That's certainly bigger than 0. So we are in between 0 and 7. Okay, so our domain is all the values of x that are between 0 and 7. Now, I have to include this, and we cannot have x cannot equal 4 as our domain. Notice here I included it because 4 is in between 0 and 7, so we can't have a 4 in the denominator, so we have to make sure we throw it away. So now we took care of our domain restrictions. So we made it a little bit more challenging than what we had from the other day. I mean, we still had the radicals, but now we had this radical over another x. So it's a double whammy. We got to worry about the top, and we have to worry about the bottom. Okay. All right, operations now. The other day when we added and subtracted our functions, we did not worry about anything with our domains. Well, now we're going to start worrying about domains as well. Okay. So when I start worrying about our operations here, we have to carry through any of our domain issues. So when I look at this f function, x can't be 3. So we got to write that little mental note for ourselves. X cannot be 3. Plug in 3, it's undefined. When I do this one, okay, I got to do a quick factoring of it. When we do the g function, right, x cannot be 0 and 3. So notice these both have 3's, can't have 3's. All right, so let's get this thing subtracted out. So right now I want us to do the operation of f minus g. How do we subtract functions? That's right, we have to have a common denominator. So what are we missing here? Oh, this one's missing they each have an x minus 3. So this one's missing the x. So we're going to multiply this top and bottom by an x. So I have x squared plus 2x minus 15 over the quantity x times x minus 3. So I can factor this. So I have x plus 5x minus 3 over x parentheses x minus 3. And now I can cancel. So we have a final of x plus 5 over x. And you're going to say you're done. No, you're not done, because we have to worry about our domain restrictions. Right now, what's our domain restriction? That's right, x cannot be 0. That's it. No, it's not it, because in the original problem, x could also not be what number? That's right, x can't be 3. So we have to include the original pieces. Because what happened is here we canceled out, we lost x can't be 3, but we cannot lose it based on the original functions. Okay? So our final answer then becomes this. When we do our operations, we cannot forget about our original domain issues. Can't lose them. All right? What do we have here? So I need my domain issues. That's right, x cannot be plus and minus 3. All right, I'll factor it out so you guys can see how I got plus and minus 3. And this will, right, x cannot be 0 and a 3. And again, I'll factor it out so you can see how I got that. Now it says I'm going to add these functions together. Right, in order to add, we have to have a common denominator. So, first of all, this one's messed up because it's 3 minus x, so let's get that fixed right now. So if I switch this around as an x minus 3, what do we have to do up top? That's right, we have to multiply by a -1. All right, so they both have an x minus 3. This is missing an x. What's missing over here? That's right, it's missing the x plus 3. So our common denominator is x plus 3, x minus 3. See it? X plus 3, x minus 3. So that's our one denominator. And up top I have a 2x minus x minus 3. All right, I distribute the negative. -1 times each of those, so minus x minus 3. So I'll collect like terms. So we have, actually to save space, to save space. So 2x minus x, I get all of this right here gets x minus 3. Now look at this, x minus 3 here. X minus 3 here can cancel. So what do we have on top when it's all said and done? We have a 1 over x parentheses x plus 3. Okay, so notice what I did. I combined my likes. 2x minus x gives me x, and I had the minus 3. So I canceled out. So I just saved myself a little space here. So now you're going to say, oh, okay, we're done. So x cannot be 0 and -3. And you're going to say, you're done, Mr. Prada. And I'm going to say, no, you're going to lose a half a point because we lost one of our domain issues. What domain issue did we lose? That's right, we lost the +3. Okay, because it canceled out right here. But we can't lose it because it's still in the original problem. We had a +3 here we had to keep issues with, and we had a +3 here. So we cannot lose those issues. All right, no losing domain issues. That's the whole key when we're doing our operations. Can't lose the domain issues. Alrighty. Let's have some more fun with, so now notice what I'm going to do with these two is I'm going to divide. I'm going to put the G on top and then the H goes on the bottom. What is the domain issues here? Right here, just X. X cannot be 0. Okay, so X, where am I going to write it out? Right here, X cannot be 0. Okay. All right, so let's get this set up. I want to set it up as a complex fraction because it'll be easy for me to solve. What's our common denominator? That's right, we're going to multiply everything by 9x. So those cancel, so we have 3x plus 30. The 3x cancels with the 9x to leave us a 3, so I just have to distribute. So I have 12x plus 120. And it's just a little bit of math. Let's say I can factor out a 12. Here I can factor out a 3. And so what are we left with? We're left with 4. All right. X plus 10s cancel. 3 goes on 12, 4. So we're left with 4. And you say, oh, we're all done, Mr. Prada. And I'm going to say, no, you're going to lose points. X does not equal 0. And, that's right, negative 10. Where did negative 10 come from? Well, right there. In this problem right here, x cannot be what number? That's right, x cannot be negative 10. So we have two domain issues in this one that we can't lose. So 4 is the answer. X cannot be 0. X cannot be negative 10. Be careful when you do your operations. All right, look at this one. Here we're going to do an a squared, and then we're going to multiply a times the c. So what are our domain issues? Well, right here, right, x has to be strictly greater than 0 because the radical's in the denominator. You cannot have 0 in the denominator. There's nothing wrong with taking the square root of 0. Square root of 0 is 0. But as soon as you put it into the denominator, then we got issues. No one defines. Here, x is greater than or equal to 0. All right, a squared. What does that look like? Well, 1 over radical x squared is equal to 1 over x. Okay? So what's our domain? All right, our domain is still... Now, here you're going to say, oh, okay, x can't be 0. You're right, x can't be 0, but the original domain issue was x has to be greater than 0. So we cannot just say x cannot. If you just do this, that's wrong. Okay? Because the original problem was 1 over square root of x. So this would be incorrect. We have to say x is greater than 0 because that was the original domain issue. Just because we squared it doesn't mean things changed. All right, so now this is the correct answer. 1 over x such that x has to be greater than 0. All right, here's another unique one. Look at this. We're going to multiply these two things together. Don't forget your domain issues. So I have 1 over radical x times radical x. So this just equals 1. So that product is 1. But what are we going to say for the domain issue? Okay, we have to go with the most restrictive, which is this one right here. X has to be greater than 0. Because if I chose this one as my domain issue, we can't have the equal 0 here. So we have to go with the most restrictive, which is this one. So the answer is 1, but we have to say x has to be greater than 0. All right, finally, the last ones. This is really, really fun. I'm going to give you sets of ordered pairs. I'm going to ask you to add the functions together. Well, what's the only way that we can add functions or subtract functions or multiply functions or divide functions? The domains have to be the same. Okay, that's the only way that we can add functions. So there's not a lot here that we can add. Let's look at the ones that we can add. Or subtract, multiply, or divide. The domains have to be the same in order to. So in order to add, subtract, multiply, divide functions must have same domain values. So in other words, our domains have to match, and then we add, subtract, multiply, divide range values. Okay, then add, subtract, multiply, divide range values. So what does that look like? Well, let's look at the list here. What are the only ones that we can play with? I'll highlight them. All right, 2, 3, and 2, -1. Does the 4 match with anything down below? No, it does not. So you know what? I'm just going to get rid of it. Does the 6 match with anything down below? Yes. 6 and the 6, 0. Okay. All right, these two match. That's right. So we can do these. We can do those. And then I have nothing for 3, 8. There's no 3 up here to worry about, so we don't have to worry about that. So these are the only, so we're only going to have 4 answers here. So when I do A plus B, I'm going to do 2, comma, and then I'm literally going to add 3 plus a negative 1. So that's 2, because I literally did 3 plus negative 1. So now I'm going to look at my 6, and it's 8, right, because I did 8 plus 0. Now, when you remember, for addition, the order in which we write them down does not matter. But if it was subtraction, make sure you write them down properly. All right, so then we have what? Negative 7 and then 0 plus 7. So that's 7. And then 0 and then 3 plus a negative 5. So 3 plus a negative 5, which is negative 2. There. So we just added those. All right, now division's the exact same thing. Or A divided by B, the exact same thing. The only ones that we can do are these. So we already know what the domain values are going to be. So we have a 2, a 6, a negative 7, and a 0. Okay? So now it's just a matter of what's the y values. Well, 3 over negative 1. Well, 3 over negative 1, so that's negative 3. 6. 8 over 0. 8 over 0. Wait a minute, that should give you some, that your bell should be going off in your brain. That's right, we can't have 8 over 0, that's undefined, so this doesn't exist. Because 8 over 0 does not exist. Okay, so I cross that one out. All right, now here, negative 7 is fine. 0 over 7, there's nothing wrong with 0 over 7. 0 over 7 is 0, so we have negative 7, 0. And then finally we have 3 over negative 5. So we only have 3 answers here. No big deal, there's only 3 answers. This one did not exist. 8 over 0 doesn't work. All right. Now, the last one, number 6. I know I went over these a little quick, so, watch the video again. Rewind. All right, last one. Same ideas. The only way that we can add, subtract, multiply, divide functions is if the domains are the same. Well, what do you mean you don't know the domains? Yes, you do. You only have 4 domains to worry about. These are the domain values that you're worrying about. A 1, a negative 3, a 5, and a negative 7. Okay, so I only have 4 of them to worry about. So here is the function that we're dealing with. So I don't have to worry about every single domain that's ever possible for this function. No, the only domains I have to worry about are the ones that are going to match these 4 ordered pairs. So the first one that I have to worry about is 1. So let's create the ordered pairs for this d of x. So this d of x, we're going to make the ordered pair. So down over here with my scribbles, I'm going to do the work. Over here on this side, I'll write out the ordered pairs. So, all right, 1, x, and y. All right, so we got a 1. So what does that mean? Well, if 1 is the x, I'm going to plug it in here and crunch out a y answer. So I'm going to do 1 plus 3 over 1 minus 5. So what do we have? 4 over negative 4, which is negative 1. So when x equals 1, so d of 1, the y value is negative 1. All right, now I'm going to do negative 3. So d of negative 3. So negative 3 plus 3 over negative 3 minus 5. Oh, that's 0 over negative 8, so that's just a 0. So at negative 3, we have a y value of 0. I got to squeeze this in somewhere. 5. Or am I going to do 5? D, I'll do it up here. Somewhere in another room. So d of 5 is equal to 5 plus 3 over 5 minus 5. Well, wait a minute, what's 5 minus 5? That's right, that's a 0. 8 over 0. Can I have 8 over 0? No, so this one does not exist. So 5 comma 6 doesn't exist for us because 5 doesn't fit the domain here. That's right. If we would have said, oh, x can't be 5, and then we would have realized we wouldn't even have been able to use that. So now the last one is negative 7. So d of negative 7. So we have negative 7 plus 3 over negative 7 minus 5. So what do we have? Negative 4 over negative 12, so 1/3. Mr. Prada, there's a fraction. Wah, there's a fraction. All right, so all of this work right here was just so we could figure out what the ordered pairs were that we're going to match. And we figured out we can't even use 5, 6 because the domain value of 5 does not fit this function. Okay? So we're only looking at these 3 ordered pairs. So C minus D. So what's C minus D going to be? So remember, I'm going to put the C first. So 2 minus a negative 1. So I'll write it up above here. 2 minus a negative 1, which is 3. Now I'm going to do negative 3. So negative 3 comma. So it's 4 minus 0. So 4 minus 0 is 4. And now I have to do the 8. So negative 7 comma 8 minus 1/3, which is 7 2/3. Okay? So we just did C minus D. Now we're going to do C over D. So again, we only can use these 3. So C is on top, D is on the bottom. So 1. I'll write the fraction above it. So we have C over D. So it's the y, 2 over negative 1. So we have 2 over negative 1, which is a negative 2. And then I'm going to do negative 3. So negative 3. So we're looking at 4 over, now remember those are the matching, 4 over 0. Well, I'm going to stop right there, because can we do 4 over 0? That's right, we can't even do 4 over 0, so this one doesn't even exist. And then finally, negative 7 comma, and we're doing 8 over 1/3. So 8 over 1/3. And if you remember your complex fractions, all I got to do is multiply by 3, so we have 24. There, we just did the notes. You're going to have fun, fun, fun. Okay? I'm doing this over 2 days, folks, so you can watch the video tomorrow, but the homework won't be due tomorrow, okay? You can work on the homework on the next day, because there's a lot of stuff going on here. All right, so I have a feeling I'm going to have to go over some other things with you guys as well. All right, have a good day.